Good afternoon, everyone. This is Khaled Soleiman presenting Defense Modeling Systems. The presentation I'll be doing today will follow this. We'll go in this order. Introduction, project overview, implementation, testing and analysis, and finally conclusion and future work. The powers of computer vision and image processing enables us to create and implement amazing applications, from Face ID to color detection and also motion detection. And the project I'm presenting today is under one of these principles, which is motion detection and tracking. This project aims to create a protective system to secure facilities, properties, important places such as airports. This is my project overview. So it consists of a camera will be monitoring an interest of area and streaming the video to processing module, which is Raspberry Pi 3. When anything enters that area, which means there is a motion at any point, the Raspberry Pi will detect that and indicate the XY coordinates of that object, of that motion. And then it will send the coordinates to Arduino Uno, which will derive the motors of the tracking machine toward that point and then shoot it. By shooting, I mean just blinking a laser on that point. These are the major components I'll be using: Raspberry Pi camera, Raspberry Pi 3 module, Arduino Uno, and stepper motors. First part of the implementation is the software. Here I'm using open free source Python code, which is written to capture frames from the Raspberry Pi, compare them, and I modify it to indicate the coordinates and then send it to my Arduino. The software part works as follows. First, it will capture a frame from the camera, and shortly after that will capture another one, and respectively compare each pixel from the first frame with the same pixel position of the second one. And when there is changes, return the XY coordinate of that pixel. Second part, I draw this draft of my mechanical machine with AutoCAD in 2D dimensions. And later on, I got 5 millimeters thickness transparent acrylic glass to implement the mechanical parts. Next is the block diagram of the whole project, of the whole electrical and mechanical parts. Here we see the camera is connected directly to the processing unit, which is the Raspberry Pi 3. And the Raspberry Pi 3 sends the coordinates to the control unit, which is Arduino Uno, by serial communication. The Arduino Uno is connected directly to the H-bridge motor drivers, which will send signal to the motors respectively to move the mechanical part toward that motion point. At the same time, the Arduino will also send a signal to a relay, which is connected to a small laser pointer to indicate that point. After getting the software done, modifying the software and getting the mechanical parts, I assembled all together, and I got my very first prototype project. this is how it looks like. Then I started testing. This is the testing for the software. When I moved or someone else moved in front of the machine, of the camera, within certain area, the Raspberry Pi will indicate the coordinates of that motion generated on the left side, and then send it to the Arduino, which is here on the right side. Next, this is the first successful test I have done. When I tried to move within certain speed in front of the machine, it could indicate me, and the mechanical part could also track me wherever I go. After that, I have done some experiments. I tried to replace the machine on various distances from the area which is monitoring, and calculate how accurate the machine can track me, and for 5 positions, and I calculated the average for each one, each time, and for each distance. From the taken data, I draw this line. This line shows how the accuracy of the machine. It's clearly that the more far the machine can see, or the more far it's located, its accuracy will go lower and lower, for various reasons. To conclude, first, this project gave me great opportunity to learn from the world of image processing. I have learned a lot. As well, mechanical part, controlling motors. I first started searching for the right, fastest, simplest algorithm for motion detection, and then I got my materials, I got my parts, and finally I successfully got my first prototype. And next is the IECON 2018. It stands for International Electrical Engineering Congress 2018, which is held here in Thailand, in Krabi. It is the Thailand section of the IEEE. So with instructions of my advisor, I have submitted according to their standards 4 papers of my project summarizing everything. And right now my papers got accepted, and either me or my advisor will be presenting the project in the conference in Krabi between 7th and 9th of March 2018. Next, for the future work, this project is still far from being used for realistic situations. It's a bit slow. Starting from my target last semester, which is tracking ping pong ball, finally I ended up with 1-dimension tracking. Accurate, fast enough. I couldn't achieve all my expectations. Furthermore, this project is a strong step to move forward and develop the software part as well as the hardware part. The hardware part can be developed in terms of materials, motors, better controllers, and for the software part, it can be developed and adapt the facial detection with the facial database, and also spatial detection. And I mean by that detecting drones. Well, for detecting drones, it's a bit hard because the simulation of drone motion and converting that motion to mathematical equation and implemented within the software is a bit hard. So that will be part of the future work perhaps. Thank you for attention, and I think you might have some questions.
So what's the end-to-end lag of your system from the frame acquisition, when you capture an image, to like sending a command out to the stepper motor? How much is your delay?
Well, there are two, since it consists of two parts, there are two delays. First one is due to the speed of the Raspberry Pi and the processing in the background. I could get minimum delay of 380 on average milliseconds. Okay, it's a bit more for the software part, for the hardware part, the mechanical part, almost 640 milliseconds.
So more than a second.
Approximately on average a second, yes.
Sounds about right.
How do you detect the target?
Comparing two frames from the camera and indicating where the changes happens.
What if we have noise? How do you
If
noise? How you just simply subtract the pixels?
yes, simply subtract them. If subtract, the calculation is two steps. First subtract the pixels, okay? When that subtraction result is greater than certain threshold, it will trigger the second process, which is sending that coordinate at that moment. If it's not, so there is tolerant for noise, if that's what you mean.
Oh, okay.
So frame
N
plus one, and then you subtract.
Subtract each pixel respectively.
What you get is edge detection. Correct. Edge detection in terms of like motion. So if the motion is left to right, you'll see the delta edges.
I didn't calculate that.
Just subtract them. You
Yes.
just simply subtract why you take it takes 604 milliseconds. Why?
This is how it takes.
I guess.
Maybe it's slow.
How did you X all your images?
Did I?
X all your images?
No.
Subtract RGB.
Yes.
Did you search in Google how to locate the motion?
A lot.
Then this solution actually.
Explain again. How did you compare?
It will capture the first frame and shortly after capture another one after that. Okay? And subtract each pixel from the first one with the other one respectively. If the result of the subtraction is greater than certain number, okay, it will trigger the second process to send that coordinate at that point, at that pixel position.
No, I mean how you actually in the programming how you did it.
It's random.
Yeah, I mean, why is it? I mean,
Python.
abstractly.
Did you use looping loops?
Yes.
Is it looping loop? Or
This is the flow chart of the algorithm.
no, I understand the concept. Actually, how you write it. Actually,
I just use free open source software.
they get you a picture and then they.
Yes, yes.
It's a complete
The-
library.
Yes, they capture the frames by themselves, but they are meant for other purposes. I modify it to get the position of that pixel.
What's the name of that library?
There are so many, I don't
No, the
remember
one
all
that
them.
you use. What's the name?
So many.
No, the one that you pick.
Yeah, it's not only one library. There are so many. Want to read the camera module. Want to send the coordinates.
After you get the image, right?
Mm.
Where did you save it? In the matrix?
No.
Where?
Buffer.
What is that buffer? Did you get a pointer to that buffer, or did you use a library to from the subtraction?
In Python, you just declare
I'm just looking
A
for
variable?
reason that it takes 600 milliseconds. It's just absolutely slow. Very, very slow.
the reason there are so many processes in the background of the Pi.
No, there is not. Nothing. What's on the background?
There is a whole operating system working.
But they don't consume the CPU power, the CPU time. They don't.
If not, should work.
They are just like this.
It takes time to. I run a timer at the beginning of capturing the first frame, and then display it right after I get the coordinates, and this is how I calculate the time. So there is no time waste in that.
So it will only actually work at a distance of 1 meter.
100% yes. It will work further than that, but with a small error percentage.
I saw it seeing your graph. You're on almost an exponential decay there. No, that'll just, because you've got no depth perception here.
Yes.
You've only got one flat
One
plane, which is
dimension
1
picture,
meter
yes.
away from your camera.
Indeed.
So its usefulness is at 1 meter. Every step further than that, that curve is just going to go right out.
Nothing is perfect. So
Yes, but this is shortcoming. There's no depth perception. You've got no stereo.
yeah, it's
effect,
2D view only.
or you've got no rangefinder. So you've got no way of knowing from that picture how far that object is away from the camera.
Yes, that's unknown.
So when it moves 1 centimeter in your frame, that could be anything.
Yes.
Literally.
Yes.
Except at
Depends on the distance. It can be anything.
Except at 1 meter distance.
Yes.
So when you subtract two consecutive frames from each other, if there is zero motion, the difference will be zero.
Yes.
Now, if there is motion,
Not always the difference will be zero. At certain point there is light. Someone is using flash. There is extreme small noise which is tolerant within that.
so you said first one.
Yes.
So I got the problem that you have. You using a command, right, to capture one image, and the way that you use it, that's what's on the underlying task is like this. You capture the image, you
Mhm.
save it in a hard disk. It takes so much time.
That's part of the previous what's it's meant really. It will save nothing.
So what's the output of this RAS still?
It will just capture the frame. It will not save it to the hard disk. It will not save.
Capture the frame and put it there.
Put it in the buffer.
RAM?
In the RAM, yes. Nothing will be saved. That was the previous purpose of this code. Yeah, I mean it was meant to capture pictures when there is motion. So I ignore that part and modify it to get the position of that pixels.
I mean, you didn't update the report.
Maybe some part, no, not 100%.
So image n plus 1, when there's motion, if there's, so you measure the amount of pixels, proportion of pixels that change.
Yes.
Okay. I see. At first I thought, if you subtract it, you will see an edge outline of motion, right? And then you use edge to find the center of what's moving. But instead you only just like
Not subtracting the whole frames, pixels of them only.
And you go.
pixel of the whole frame, right?
Yes.
Of the whole
Each one.
one by one.
And what exact pixel did you record? Which one did you use as a coordinate?
Which one?
The coordination of your target. Imagine a very big object moving, right? And you
Mhm.
have a big rectangle.
Ah,
Which one will be your target?
okay. According to the fundamental principle of image processing, when we read a file, we will read it as follows. From the very top left point, which is the origin, 0, 0, until to the maximum left down point, which is according to my scale, it's 99, 99. So comparing two frames, suppose this is my camera view and I move to this point. Comparing the previous frame with this one will give a result of this point, exactly this position. Because I'm reading from up to down and left to right. So I will get this one. There is scaling to move a bit further than that. This is the coordinate I will get actually,
But when you
not at the center of the object.
that's interesting. So,
Yes.
so just at the upper left-hand corner of the motion.
The first point where I get changes.
Oh, okay, I see what you mean. But in that case, how do you name it correctly?
Yeah, you cannot do that. You cannot run correctly.
That's why there is a bit error percentage.
So will it aim, that upper left-hand corner of where the change starts, those coordinates will be set to the stepper motor, right?
Indeed.
Okay, so pretty much what you have is similar to something that will shoot a rose off somewhere.
There is scaling to go further than these exact coordinates. I mean, the motors will not run exactly according to these coordinates. It will rotate a bit more
By how much more?
by
A constant?
yes, a constant. Yes, it is a constant.
Which you set, right?
Yes.
So that means if we're very close, bullseye between the eyes. If we're very far away.
Shoot to zero.
Yes. Yes.
Okay.
Yeah, you could take the average at least, the average of the points. The average of the coordinates, right?
The center of mass
Yeah.
of like the changes, right?
Well, couldn't you have taken both sides and averaged? Is that what you're saying? Taken both sides?
Subtracting from the both sides. That might work.
Unless the target is like donut shaped or arch shaped, then so in the center.
Or if it's changing shape?
That's even more difficult.
But the timing is just unacceptable. 600 milliseconds.
For the hardware part, yes. For the mechanical parts, yes. Actually, my motors are quite powerful, and 1000 RPM should be enough to create faster response. But the point is, I couldn't use exactly the 1000 RPM because when it moves that with that speed, okay, and then stops, it will create some reaction on the whole machine. The whole machine will a bit shake. So I couldn't use the full speed of the motors due to the weight of the machine.
Wait, I search for background subtraction and timing. How long does it
You know, we're all computer engineers over here, right? So typically, what we're worried about is like, why does it take so long? Number one is it could be the device latency itself, right? What is the frame rate of the said camera sensor? Number two, what's dumping? What is the word size that gets dumped from that device? Does it get dumped in characters, which means 8 bytes, words 16, 32, 64? How fast? What's the clock rate over that device bus? And then you put that in the CPU reads that, or is it through VNA? And does it go into memory that's eMMC, or is it through the RAM? Is it actually RAM? Then it's held in a buffer, right? And then you take the next frame and subtract it. So there's 390 days for the electronic part, right? Acquisition frame 1, frame 2, subtraction.
Okay, I really didn't go up to that level, okay, but I see it is a bit, it has a low performance. I tried to solve that first by disabling the GUI of the Pi, so it will run just the core operating system without GUI, without extra unneeded processes in the background. It didn't help. I tried, there is a common sense, I'm using Raspbian, which is based on Linux. Raspbian.
It's based on Debian.
Based on Debian.
Right?
So it has Linux command.
You can use Linux commands, right? So one of the commands you can use is top. shows you the CPU utilization of all the processes currently, right?
Yes.
And then you can subtract and see how much CPU percentage of that.
I tried to run my program with renice comment and maximum 19, the highest priority. That also didn't affect much the processing time.
That meant that the kernel wasn't taking much time in the first place. So that's almost like full performance. This is my
Yes, it is.
And the acquisition was done through Python.
Yes.
Interpreted or compiled?
Interpreted.
Did you convert on grayscale?
No.
So what did you subtract? The R value, RGB value?
RGB values, yes.
It's a color camera, right?
Yes. Yes, it is.
So you can change the acquisition format to black grayscale to be faster. If it's RGB, then you'll be take all the
Okay.
So, you see, now I just took 2 minutes to search online. It's possible to have 20 frames, means 25 times per second, and perform the background subtraction. 25 times per second. For 800 times 600 frames. 800 pixels times 600.
What's your acquisition rate?
Something is wrong with the equation.
No, that's in the beginning I asked about the way you program because it might be because of the looping itself or
Yeah, maybe you didn't get the pointer, the direct pointer to the memory, right? So you are accessing those cells indirectly, and there are some calculation, things like this. 600
Okay.